Hello everyone, this is Salman Patan from Math.0 channel. So today we are going to see problem which is based on Gauss-Siedel method. So our question is solve following example with Gauss-Siedel method, and we have x plus 10y minus 2z equals to 16, 3x plus y plus 15z equals to 52, 12x minus 2y plus 3z equals to 18. Now first of all we are going to write this in ax equals to b form. So the value of a is this 110 minus 2 3 115, then 12 minus 2 3, then value of x is unknowns x y z, and value of b is this RHS 16 52 and 18. Now in next step we are going to rearrange our given matrix in the form of partial pivoting. Partial pivoting means the element which is in first column have higher magnitude. So as we compare the elements of the all the equations, that is 12x minus 2y plus 3z equals to 18, x plus 10y minus 2z equals to 16, 3x plus y plus 15z equals to 52. So we are come to know that this equation 12x minus 2y plus 3z equals to 18 have uh, a term of higher magnitude in first column, that is 12. So this will be our pivot row. So we will write this row as a first row. And in Gauss-Seidel method we are also considering the diagonal dominant matrix. Now what is meant by diagonal dominant matrix? So diagonal dominant matrix is a matrix whose diagonal elements are maximum in corresponding row. So if you consider this diagonal elements 12 10 15 are maximum uh, in the diagonals. If you are taking the diagonal elements other than that, then it will be a minimum in this case. Okay, now in next step we are going to write this equation, that is 12x minus 2y plus 3z equals to 18 in form of x. Okay, so from this equation the value of x will be 18 plus 2y minus 3z upon 12 here. Okay, then value of y from this second equation will be 16x plus 2z upon 10, then value of z is 52 minus 3x minus y upon 15. Okay, now as we are using Gauss-Seidel method, so now we have to do iterations. Now in iteration first of all we are going to put value of x0 is equals to 0, then value of y0 is equals to 0, and value of z0 is equals to 0, and call that iteration as the iteration number 1. These are our initial guesses. Okay, now in iteration number 1 we are going to put x0 is equals to 0, y0 is equals to 0, z0 is equals to 0 in this. Okay, so it will become x1 is equals to 18 plus 2 into 0 minus 3 into 0 upon 12. After solution you will get x1 is equals to 1.5. Now in next step we are going to replace the value of x1 in this equation, not value of x0. This is very important thing you have to remember. Okay, now for next step we have value of x1 is equals to 1.5, value of y0 is equals to 0, and value of z0 is equals to 0. So in next step y is equals to 16 minus value of x, that is 1.5, plus 2 into 0 upon 10, you will get y is equals to 1.45 in first iteration, that is y1. Okay, now in next step the value of x will be this 1.5, value of y will be 1.45. Okay, and we are going to find the value of z. So after putting these values 52 minus 3 into 1.5 minus 1.45, you will get answer of 3.07. Okay, so these are the values. Now this value will be our x1, y1, z1 for iteration number 2. Okay, now in iteration number 2 we are going to put the value of x1, y1, z1 to find the value of x2. Okay, so 18 plus 2 into value of y1 is 1.45 minus 3 into value of z1 is 3.07 upon 12. Then you will get the value of x2 as a 0.9741 by putting the value of y1 and z1. Okay, now for y2 the value of x will become 0.9741, the value of y will be 1.45, the value of z will be 3.07. Now after putting the values of x, y, z, you will get the value of y as 2.1165. Now next z2. For z2 52 minus 3 into previous value of y, that is y2 0.9741 minus 2.1165. Okay, divide by 15, you will get 3.1307. In this we are putting x2 and y2's values. Okay, now in iteration number 3 we are going to get or assume the previous values, the values of x2, y2 and z2. Similarly, by putting these values, you will get x3 is equals to 1.07008. Then in case of y3 you have to use the previous value of x and the assumed values of or the values which we got from iteration number 2 of y and z. Similarly, you have to find z. Then in iteration number 4 similar steps you have to do. Okay, you will get these answers. For y3 you will get 2.1191, for z3 you will get 3.1113, for x4 you will get 1.0753, for y4 you will get 2.1147, for z4 you will get 3.1106 by following same procedure. Okay, now up to what iteration we have to do this. Okay, so if the accuracy is 0.001, then we have to stop there. Okay, up to iteration number 4 we are not getting accuracy of 0.001. Okay, now in iteration number 5 we have did the same operations to find the values of x, y and z. Now similarly we have to find the value of y5. You will get 2.1146 by putting the values of x and z. Then if we calculate the accuracy, you will get 0.0005. That is, the condition of getting accuracy of 0.001 is satisfied. So here we have to need to stop, and the values of x, y and z will be, the value of x will be 1.0748, then value of y will be 2.1146 and value of z will be 3.1107. Okay, now for rechecking we will do, as it is 3 by 3 matrix, so we will do by calci. Okay, now go in mode, select equation by tapping 1, then select unknowns, that is 3 unknowns. So value of a1 is 12. Okay, then value of b1 is -2, value of c1 is 3, value of d1 is 18, value of a2 is 1, value of b2 is 10, value of c2 is -2, value of d2 is 16, value of a3 is 3, value of b3 is 1, value of c3 is 15, value of d3 is 52. You will get x is equals to 1.0747. By round off you will get 1.0748. That is, the answer we got for x is correct. Okay, now for y, you will get 2.1146. That is, the answer we got for y is also correct. Okay, and for z you will get 3.1107, and for z we also got the same answer for z. Okay, so this method is quite simple method, and for verification you can also refer the MATLAB code